Hi everyone, welcome back to Tech Learn and Play. In this video, we're going to be taking a deeper dive into the Verilog code that was used in our last video. We are basically breaking up the code from the last video into smaller parts to better understand how the Verilog code is implemented onto the FPGA. Here is how we want the board to behave by the end of this video. First, we have two LEDs, always on, one blue and one red, and we want these LEDs to turn off anytime a push button is pressed. For example, if we press both push buttons, both LEDs turn off, and if we press one, one turns off, and if we press the other turns off. All right, now that we have a good idea of what we're expecting, let's go ahead and hop into programming our FPGA. All right, so now that we have Avado open, we're going to go ahead and create our new project. So we're going to go here, all right, and we can just name this Cora LED 2. Go ahead and keep all the defaults as usual. Instead of bringing in our own source files, we're going to generate it from scratch. So we can just push create, and I'm just going to label it top for now, and go ahead and keep the defaults. And then the constraints file, we're going to get it from a zip file that Digilent has of all the different constraint files for the different boards that they have. For example, here's our Cora Z7 master. I will include the link to that zip file in the description below. We go ahead and continue. Go ahead and go to boards and then type Cora Z7. So it's stuff that we did in the last video. We can go ahead and finish that. All right, and we're waiting for that to initialize. And this is just default. We don't have to put anything here. In later videos we could, but we're just going to keep the default for now. So that it generates all that information. All right, so now that it's finished initializing, we can see all the different files that it created for us. Here we have our top file, which just has all the default information of the files that they create for us. And then here is the Cora Z7 master constraint file. Pretty much has all the ports that we would ever need on the Cora Z7, but as you can see, this file is doing nothing currently just because everything is commented out. And whenever we do need to use something, we can just remove this hashtag and it would allow us to use that port. So here, first things first, the first thing I like to do when creating code is actually figuring out what we want to do. And for this video, we want to accomplish two tasks. The first is a simple program to have two always-on LEDs, one blue and one red. This is so that we can understand the basics of just turning on an LED. The second task is our goal and what was shown at the beginning of this video. In this task, we will add logic so that when a push button is pressed, its respective LED will be turned off. For example, if button 1 is pressed, LED 1, the blue LED, will be turned off. Now we can go ahead and hop into this. So for here, this is a module. Module is pretty much just like a black box that takes in inputs and produces outputs. It is identified by the module keyword, followed by the module name, and then inside of here we have the port list. This is where we're going to include our inputs and outputs, and the purpose of a module is just so that it can produce the functionality of a specific circuit. So for here, the way we want to begin is we want to do our first step. We want to have two always-on LEDs, one blue and one red. And that's going to be pretty simple because we don't need any inputs for this. We just need two outputs because nothing is controlling these two LEDs. They're just going to be on no matter what if the FPGA is programmed. So first things first, we need to have two output wires, and that's going to be two LEDs, and that is going to be based off of this master constraint file. So for LED 1, we want a blue, and for LED 0, we want a red. So we're going to uncomment those so that once we create the bitstream file, we can be able to program our device effectively. All right, so we can go ahead and save that, and we can go here, and now we have output wire, and this is where we would use the name that was included here, LED0_R and LED1_B. So if we begin LED1_B and then output wire LED0_R. And that's pretty much all we need in order to, in the port list of this module so far. In order to actually turn on these LEDs, we are going to have to assign the value of 1. That is what allows the LED to turn on. So we're going to just do that with the assign command. Assign LED1_B is equal to 1:B1. And the same thing with LED0_R is equal to 1:B1. So this syntax pretty much just says this is a binary string with length 1, and that's being assigned to this wire. And so whenever we use a wire, it has to use this assigned variable. And the reason why we're using wire is because later on in the next videos, we're going to want to be able to transfer this variable through different modules, and that can only be done with a wire and not a register. So now that this is done, this should be able to satisfy our requirement here. So we're going to go ahead and save that and go ahead and just generate bitstream just because I think it takes too long automatically clicking run synthesis implementation and generate bitstream. If you just click generate bitstream, it does it automatically for you. All right, now that it's done, we're going to go ahead and open our hardware manager, and it's time to program the device. So just go to open target, auto connect, and it should find our FPGA for us. Once it finds it, now we can actually program our device just by clicking program device. And this is going to program it with the bitstream file that we just generated. All right, now that our device is programmed, let's take a look. And as you can see, if we press any of the buttons, the lights don't turn off, but we do have 2 always-on LEDs, one red and one blue. So as you see, it works as expected. All right, now that we have successfully completed our first task, we can go ahead and move on to our second, which is actually where we add the logic for whenever we press a push button, it will turn off the respective LED. And in order to do that, the first thing we have to do is add 2 inputs to our port list. This is what's going to be used to actually control the LEDs. So in our case, that's going to be 2 push buttons. And if we don't know the exact name, that's where we can go to the master constraints file and see what we're going to use as our inputs. For us, we are going to use these 2 buttons, button 0 and button 1. So all we have to do is uncomment these 2 lines out. If we forget to uncomment these lines out, then we will not be able to generate the bitstream correctly, and it will error out, and we will not be able to program our FPGA. So if we go ahead and declare it in our port list, all we have to do is put input wire, and then it's going to be an array of buttons, 1 to 0, and that's it. And we have declared our input variables. Now that we have declared our inputs, now we can go ahead and declare a temp variable. We want this temp variable so that it will store the values of the LEDs when it's running through the code. For example, right here, this is where we're going to want to assign our temp variables. So in order to do that, we're going to do reg, and it's going to be an array just like our button, and it's going to be LED on. You can name this whatever you want, but in my case, I'm just labeling it as LED on. All right, and just like before, this 2 stands for the length of the variable, and it's binary 1 and 1. So each one of the LEDs is going to be on at the start. All right, and now we can go ahead and assign this just so that we don't forget. So this is going to be LED on, and blue is LED 1, so we can go ahead and put 1. And this is going to be LED on of 0, because it's LED 0. And all right, so now that we have done that, we can go ahead and create the actual logic statements. And we are going to do this inside of an always block. Always blocks are extremely helpful because they only run whenever the value inside of these two parentheses has changed. For example, if I put button, this always statement will only run if there's a change to this button variable. So if I press a button or if I let go of a button, this will run, which is what we want. And so in order to do an always statement, it has this always keyword, this at, and button. In the next episodes, we're going to have the value inside of here be the positive edge of a clock, so that every time it's on the positive edge of a clock, it will run a certain code. And so in here, we're going to do begin and end. That is how an always statement is set up. Now, inside of this always statement, what do we want to do? So what I like to do before writing code is to write what I want to happen in human words. So what do I want to happen? Pretty much if the button is pressed, then turn off LED. And that's it. Pretty straightforward. So now to actually write the if statement in Verilog, it'll just be if button 0 is equal to, and if we're pressing the button, that means it's high. That means it's on. So that means it would be 1v1. So if the value of button 0 is equal to 1, what do we want it to do? Begin, end. I always like to put the beginning and end just so I don't ever forget. What do we want it to happen? It pretty much says turn off LED. So that's going to be, write that by doing LED on is equal to, which one do we want to control? Which one do we want to control? LED 0, because that's the respective to the button. So that's going to be equal to 1v0. And that turns it off. All right, great. So now, what do we want to do if that button isn't pushed? If that button isn't pushed, then we want to leave that LED on. So let's add a little else statement here. Begin, end. Okay, and now what would we put in here? LED on of 0 is equal to 1v1. So pretty much if that button is not pressed, set it to high. We want to see that LED on if there's no button being pressed. So that's pretty much all we have to do for LED 0 and button 0. And because we want the same action to happen on both buttons on both LEDs, we can go ahead and just copy this if statement and just change the index. So in here, button 1 and LED 1. And now we should be set. And we've already changed our code here so that it'll set LED 0, LED 1 to 1, and LED 0 to 0. And that should be it. And we can go ahead and save that and generate our bit stream. All right, sounds good. Now let's go ahead and open our hardware manager and actually program our device. So first, open target, connect, as usual. And each time you close the hardware manager, you're going to have to auto connect the device and program it again. And so we can go ahead and program it with what we just did. Now let's see what we did. All right, so here's our board, and we can test to see if it works. And here, if we select both of the push buttons, they both turn off. If we select one, one turns off. If we select the other turns off. So as you can see, our code worked as expected, and that will be it for this video. Please stay tuned for the next videos where we'll be going further into the code of the Digilent Basic I/O demo, and I look forward to seeing you in the next one. Thanks.